Rise and shine, porcupines. It's Algebra Without Time. I'm your host, Rosetti. So today we're looking at Chapter 1, Unit 2, Properties of Numbers. So after watching this video, students will be able to use the properties of numbers to evaluate expressions. So the concept is properties, the skills being able to evaluate. So what do you say we get started, shall we? Here we go. So the first thing we have to do is classify these values. Okay, so let's look at 34. All right, so we know that 34 is a integer, right? We know that it is a whole number. We know that it is a natural number. Every term that we can write as a fraction, right, is a rational number. And then all of these are real numbers. So this one fits most of the groups. Okay, let's look at number 2. Negative 525. Well, it's not going to be a whole number. It's not going to be a natural because those are all positive. It's going to be an integer. It's going to be rational. It's going to be real. But we can write negative 525 as a fraction. 0.875. It's not going to be what? Irrational. It's not going to be what? It's not going to be an integer. It's not going to be a natural number. It's not going to be a whole number because none of those include fractions. It's going to be rational and real. Real. All right, 12 over 3. Well, to find out what that is, you have to simplify it. It's positive 4. That gives you natural, whole, integer, rational, and real. Negative square root of 9 equals negative 3. That is integer, right? Real. It is rational. We can write it as a fraction. Okay, let's take a look at this. Now they want us to identify the properties based on these expressions. So one thing I want to really relay to you, when you look at and you have to identify the properties, if they move the values around, okay, if they move them around versus just moving the order with parentheses, if they actually change the order, it is commutative. If they change the order that we do things with parentheses, that's always going to be associative. Okay, so number 1, they actually change the order, that's commutative. It's that easy. Okay, number 2, well, we know the distributive property. All of us, since we're 4th or 5th grade, we learned that. Okay, anything that is equal to 1 is the multiplicative identity. You're multiplying things by their inverses. Look at number 13. They change the order with parentheses. They don't move around the values. What did I say? That's associative. All right, anytime we're adding 0, we know that's the additive identity. Now look at number 10. Do they move the actual values? No. They move the order with parentheses, associative property. 15 times 1, anytime you're using the 1, it's multiplicative identity. And number 14, they actually rearrange the values. So that's got to be commutative. Okay? Even though there's parentheses there. All right, find the additive and multiplicative inverse for each number. Well, that's pretty straightforward. The additive inverse is whatever you're going to add to get it to equal to 0. So if you have 15, you're going to add negative 15. Pretty straightforward. So the additive identity to 15 is negative 15. Now, what are we going to do to 15 to get it to equal to 1? 15 times 1. Well, the inverse. So if it's 15 over 1, we're going to multiply it by 1 over 15 to get it to equal to 1. So the multiplicative inverse is what? 1/5. That's what you would multiply by to get to 1. All right, 1.25. Well, let's not worry about the decimal. The additive identity is negative 1.25. Let's not overcomplicate this with making it a fraction. All right, now multiplicative identity, that's a little different. Okay, we do have to put this into a fraction to be able to do that. 1.25, what, is the same as 1 1/4. So how do we make 1 1/4 into a fraction? Well, we know how to do that, right? 4 times 1 plus 1 is 5 over 4. So the multiplicative identity would be 4 over 5. All right, 17, negative 4/5. Well, once again, don't complicate things. Positive 4/5 will get you 0. And then multiplication, you're going to have to go 5 over 4. And you keep the negative. It's not asking for opposites here. It's just inverses. All right, 18. So we have 3 3/4. We don't need to change this to a fraction just for an additive identity. 3 3/4, the additive identity is negative 3 3/4. Now, to find the multiplicative identity, yes, or inverse, yes, we should put this into a fraction. We get 15 over 4, flip it over to 4 over 15, and that multiplied together gives you 1. That's what we're looking for. All right, simplified expressions, number 19. Well, we're all Algebra 2 students now, we're all big boys, and we should know that to be able to simplify this, we have to know what the like terms are, and obviously the x's would be combined and the y's would be combined, and we'd have 5x plus 2y. Looking at number 20, same thing. You can only add the x's, the y's, and the z's, and in this particular case, each one is opposite, has an opposite sign from one another, and you will get 0. Not 1, not 1y, some kids 0. All right, 21. Well, there's a part in your mathematical journey where you see a negative sign outside the parentheses. No one's going to tell you, no one's going to warn you. It's commonplace to change the signs first before you combine those like terms. So it's negative 3g, negative 3h, and that is just supposed to be standard. You know it, you do it without any explanation at this point. All right, so now we combine like terms. We got we got 2g, and we got a negative 13h, okay? Make sure you change the signs when there's a negative in front of the parentheses. All right, 22. So a squared minus a plus 4a minus 3a squared plus 1. For you to combine like terms, they have to be identical in terms of variable and exponent. So the a squareds go together, the a's go together, and there's nothing you can add to the 1. It's still part of your answer, and it has to be written in standard form. Highest exponent to lowest constant last. All right, here we go. Now we're going to do a little multiplication and then combine like terms. So we're going to distribute first and then combine like terms. So 3 is distributed, you get 3m minus 3z. Then we're going to go ahead and distribute the 5, you get 10m minus 5z. And obviously, you're going to combine the m's with the m's and the z's with the z's. Pretty straightforward. All right, so when we do that, what do we have? We have 13m, right? And negative 6z. I'm sorry, not negative 6z, negative 8z. Almost made a mistake there. That would be terrible. I don't make mistakes. I did make a mistake once in my life. I better not say that. All right, let's move on. So, 24. 2x minus 3y, there's the negative in front of the parentheses again. So standard, you know it, no one's going to tell you about it. Change all the signs inside the parentheses behind it. Negative 5x, positive 3y, plus 2z. Now combine like terms, right? So bring down the 2x, you get negative 3x. You got a negative 3y and a positive 3y, that's 0, we don't have to worry about that. Plus 2z, there's your answer. Right there, simplify. All right, 25, distribute. Now what am I looking through? When I look at 25, other than the negative 4 being distributed, there's really nothing here different that you should worry about, right? So 25, the answer, if you do it correctly, is 8w minus 2w. Not 2w, I'm sorry, 2v. All right, 26. Now the only reason I'm doing this one is because it's a fraction, but I'm not gonna do a whole lot of these again. Right now, we should be good with the fractions, but one last time. So when we're multiplying a whole number times a fraction, the math behind it is 1 times 15, right? Divided by 3. Okay, that's second grade stuff, folks. So 1 times 15 divided by 3 is 5. 1 times 3 divided by 3 is 1. So we got 5d plus 1c. 1 times 8 divided by 2 is 4, and 1 times 10 divided by 2 is 5. So there it is. So if you have this aversion to fractions, hopefully not any longer. Otherwise, what do you want me to say? All right, so in the end, what do we have? We have 10d minus 3c when it's all said and done, okay? All right. Well, that's everything. Thanks for joining me today. And remember, math, 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 go out and do some math.